Hello everyone, myself Chirag Dixit, pursuing Masters in Construction Engineering and Management from CEPT University, wearing the student code of PCM 24075. Today I will be presenting my finals portfolio for Studio 3 Integrated Construction Practices. This portfolio summarizes my learnings, workflows and outcomes across project understanding, LPS tracking, quantity takeoff and BOQ preparation. So let's begin. Starting from the project brief, the project I worked on is a high-rise commercial tower located in Gift City, Gandhinagar. It consists of 3 basements, a ground floor and 29 upper floors with a total built-up area of 66,616 square meter. The project emphasizes smart design, sustainability and efficient space planning with an excellent connectivity to metro station, highways, airport and other transport links. The project follows an item rate contract with a total project duration of 42 months starting from 1st November 2023 and ending on 19 July 2027. The overall project cost is of Rs 415 crores, out of which 160 crores is the construction cost. The scope of work which I took for our studio is basement 1 and 16th floor and 22nd and 23rd floor for LPS and 4D 5D simulation. The project's key objective is to provide premium commercial spaces and sustainable infrastructure with an iconic design and safety standards throughout the project. Through this study, I understood the project scale, stakeholders and construction methodology and the challenges involved in executing an RCC tower structure. Moving to the last planner system tracking of the design schedule. This shows week 4 of the LPS plan covering both LOD 200 and LOD 300 activities for architectural and structural modeling. Several planned tasks in Revit setup, structural modeling and architectural modeling faced partial or missed commitments. Although some activities progressed smoothly, there was noticeable variability resulting in a weekly PPC of 75%. This indicates that during week 4, the design workflow required better coordination, improved commitment reliability and smoother handovers between teams. In this slide, the data shows the LPS tracking across multiple weeks. Here, week 4 started with variability and a PPC of 75%, but as the weeks progressed, the workflow became more stable and by week 15, the PPC improved to 100%. This clearly shows how consistent coordination, better constraint removal and disciplined weekly planning significantly improved schedule reliability. The LPS framework helped bring predictability and reduce rework in the design stage. Moving on to the quantity takeoff part. The quantities were calculated manually and Revit based for the studio's scope of work, which is basement 1 and 16th floor for LOD 300 architectural model and LOD 300 and 400 structural model and all the LOD 300 MEPF models. So starting from the structural models quantity takeoff. Here the quantities for basement 1 and 16th floor were compared between Revit and manual methods. Revit provided slightly lower cost estimates with a difference of approximately 1,27,500 and a very small variance of 0.04%. This shows that model-based quantity takeoff is highly reliable and minimizes human calculation errors. Now focusing on the quantity takeoff of architecture model. For architecture elements, especially AAC walls, there was a noticeable difference in quantities between Revit and manual methods. Doors were exactly matching in both the methods. Therefore, the overall cost difference came to be around 1,52,550 and the variance was around 1.06%. This result highlights how model accuracy directly influences material estimation and budgeting. Now for the quantity takeoff of mechanical model. For the mechanical discipline, quantities of ducts on the 16th floor were compared. The difference between Revit and manual quantities was minimal, with a cost variation of around Rs 898. There was no difference in the count of duct fittings, confirming precise modeling and consistency in the mechanical layouts. Now for the quantity takeoff for mechanical model elements such as chilled water return and supply systems, the Revit and manual quantities showed a cost difference of Rs 4031. Fittings such as butterfly valves and ducts fittings match exactly in both the quantities. This again demonstrates the reliability of model-based quantity takeoff, especially for MEP components where alignment and routing play a major role. Now here we will be focusing on quantity takeoff of structure model at LOD 400 level. Here reinforcement quantities for the 22nd floor were extracted. Revit showed a total requirement of 114.66 tons of steel with heavy reinforcement concentrated in slabs, columns and shear walls. This helped understand the high strength requirements and the structural load distribution patterns. And for the manual quantity takeoff for the same floor resulted in 117.60 tons, which is only 2.56% higher than the Revit model. This close alignment verifies that the accuracy of the BIM model shows that structural elements were modeled with high precision. Now for the reasons of variance. A major variance has been observed in mechanical quantity takeoff, in which a clash was identified between a pipe and a duct, and the variance occurred because the pipe was colliding with the duct in the model, which required rerouting of the pipe alignment. To resolve the clash, the pipe was taken above the duct, leading to a difference between the manual and Revit quantities. On the second floor site photo, as you can see, the pipe was installed below the duct due to the available space, though this is not an ideal practice. At the 16th floor, the pipe was correctly placed above the duct to follow best practice and avoid the false ceiling. So after all the quantity calculations, BOQ was prepared for all the models, and here BOQ of structural model is shown, in which structural elements such as shear wall, column, beam and slab are shown, and quantities were extracted from Revit and SOR rates were taken. To conclude, this portfolio provided a complete understanding of project planning, modeling and construction workflows. The LPS tracking strengthened my skills in constraint identification and weekly planning reliability, improving PPC from 75 to 100%. Model-based quantity takeoff in Revit proved highly efficient, accurate and reliable when compared with manual calculations across structural, architectural and MEP disciplines. This accuracy also supported the preparation of a robust bill of quantities, enabling better budgeting, procurement planning, and cost control. Overall, Studio 3 integrated construction practices has been a comprehensive learning experience that connected digital modeling, planning techniques, and real site conditions into one integrated workflow. Thank you for your attention.